In this video, we are going to learn how to handle a page fault. So to begin with, we need to know what is meant by a page fault. What is a page fault? Access to a page marked as invalid is called as a page fault. What does this mean? This means whenever the operating system needs to execute a particular page, what it will do is it will look for the page in the main memory. And if it finds that that page is not available in the main memory at that moment, then you say that access to that page is marked as invalid, which means the page is currently not available in the main memory. So this is what is meant by a page fault. So we are now going to learn how the operating system will handle page faults. So there is a very simple 6-step procedure for the operating system to handle a page fault. Let's now look into the 6 steps in detail. Now, step 1. Now look at this diagram which is shown here. Now let me tell you what is what. Now here, this is the instruction that is being currently executed, right? So what will happen is from here, it will check whether the given page is there in the main memory or not. So this is my instruction given. I have represented the operating system here. This is the page table shown here. And this is the depiction of the physical memory or the main memory. And this is the depiction of the secondary memory or the backing store or the hard disk. Now, the first step is, step 1 says, now whenever a particular instruction is executed, the OS has to check whether the instruction is there in the main memory or not. Okay, so the first step will be, it will do the reference. It will check whether that is there in the main memory or not. So the reference will be done with the page table where that particular page resides. Okay, so that is step 1. In step 2, assume that that particular page is not there in the main memory. So if that page is not there in the main memory, what will happen? A trap will be sent to the OS. That is, if the page is marked as invalid, which means the page is currently not available in the main memory. Hence, it is a page fault. So whenever a page fault occurs, immediately a trap will be sent to the OS. What is meant by a trap? It's a software interrupt which is being generated to indicate that that particular page which had been requested is currently not in the main memory. So now the OS has to take some action. So once the OS receives the trap, what the OS will do is, the third step is, the OS will check whether that particular page is available on the secondary memory or not, on the backing store. So the OS will try to check for the page, and if that page is available in the backing store, it's a responsibility of the OS to bring it back and load it into the main memory. So this is step number 3. What is step 3? OS is checking whether the page is there on the backing store or not. So step 4 is, once the page is located on the backing store, it will be put into the main memory. From the secondary memory, it has to be loaded into the physical memory. So for loading the missing page into the physical memory, there should be space for the missing page. So for that purpose, the physical memory will be checked whether there is any free frame available. All of us know that the physical memory will be divided into equal size blocks, which are called as frames. So the OS will check whether there is a free frame available in the physical memory. And if a free frame is located, what the OS will do is, it will bring in the missing page and put it into the free frame. This is step number 4. And step number 5 is, once the free frame is loaded with the missing page, the page table has to be reset with the new content. That is, why it has to be reset? The reason is, the page which was previously missing is now available. So we said that page fault means access to a page marked as invalid. So now the page is no longer invalid. It has to be changed into valid. Hence, the valid invalid bit will now become valid. That is what is meant by resetting the page table. Once the page table is reset, the last step will be, the instruction load M has to be restarted. So that is our last step. So 6th step will be restart the instruction. So this is these 6 steps, step 1 to 6, clearly depicts how a page fault is handled. Step 1 is when you have so I'm going to refresh it once again. Step 1 is when you have a reference to the particular instruction in the page table and you find it is not there, then you call it as a page fault. Access to a page marked as invalid is called as a page fault, which will cause a trap to be sent to the OS. And that is step number 2. Your step number 3 is OS will check whether the page is on the backing store. And once the page is located on the backing store, the OS is responsible for bringing in the missing page by locating a free frame in the physical memory and loading it into the free frame. Once this job is done, then your step 5 is reset the page table with the new values, that is converting the valid invalid bit from invalid to valid. And finally, your 6th step will be restarting the instruction. I hope the steps in handling a page fault are very clear for you. Thank you.